of these things make sense. Back to the original question from Stephen about versioning schemas, the migration piece is so well described that it's a black and white scenario compared to having a V1 versus V2 on a canonical model. Those overnight batch jobs to convert one schema to another are error prone. It was never 100% smooth anywhere I worked, and worse in places like I mentioned before. It wasn't even possible for some version upgrades, and the companies were forced to do backports for features, which is just crazy. So yeah, everything in between. I hope you're getting a few pointers and kind of answers to kind of help you think along these new lines of event, if event sourcing and event driven is new for you.
Absolutely. Thanks.
Yeah, and especially for people getting into computer science and stuff like that, it's a model that is easier to reason about it. But the most part, the entire world is asynchronous, and then you have to map it back to weird workflows that we're trying to mimic with complete different mindsets.
I remember going for the first time, because I used to program as a kid and all that, and I learned how to, just program and learn about for loops and even assembler and all these different things. And then I remember this, I had this fear, like a total fear of the unknown, going to the corporate world of enterprise development, thinking like these scary databases, there's, SQL tables in there. Like I never had to deal with a SQL table. I was just, hacking on games and graphics and all this kind of stuff. Actually, I was doing harder stuff. I didn't realize, but this was alien to me. So I had total baby duck syndrome going into, enterprise software development. And it was very strange. So I think if you're out of school, you probably have also learned a lot of comp sci type of topics. You probably learned about, big O notation and how complex things are. Maybe these days you're doing some cool AI stuff. But going into the real world, you're like, oh man, how do I deal with this framework or this database? I'm going to need to learn all this stuff that they really didn't spend enough time on. And you're bombarded by all the different products that they can be using, all the different flavors of databases, add-ons to databases. And so I think if school starts to teach that, hey, this is state, and it doesn't matter what tools you're using, don't think about them, because in the end, this is state. And if you think about just writing a file as a record of something happening, it's as good, if not better, than writing a record in a table. That's it. I've never had that in my schooling, that level of confidence that these things transfer from discipline to discipline, whether you're going from, computer game programming to being, insurance or banking. There really isn't a difference. They're information systems. And, the information in a video game flows a lot faster. You got to think there's other SLAs on a different scale that you're dealing with, but it is state. What does each player see on their screen? How soon did you react to the event of someone pressing a button, right? Notice the same thing carries through this whole thing. So thinking about it this way is a lot superior. So if we didn't have this artificial difference between, storing state in a line of business application that's some bank versus storing state in memory in a video game, it's pretty much similar. So I'm hoping that through event modeling, we can show those similarities. Through event sourced systems, we can show that we can remove ourselves from technology to rely on state itself, and that these things that we think are a big deal. They're just a means to an end. They're not as important as their vendors want us to think, right? So you must use Oracle. It's the best. You definitely can't solve your problems with Microsoft SQL Server. You need Oracle. Like, what kind of arguments are these?
Yeah, just take into consideration the code that you did the other day in C#, Adam.
Yeah.
Like, I know you touched this guy. Yeah, it's kind of messy, but the core of what the thing's supposed to do was there. No databases were in place or anything. I was just basic mutations, and that's it. But that's
Are you
the
talking about
actual
the time
system.
tracking application?
Yeah, the time tracking.
Oh, yeah, yeah.
Because remember, I focused kind of like, how can you make this clean on that? It's kind of like, you mentioned like whatever, but the code is there. It does work, and it's focused on what the problem is. It's not focusing the tools around it. It's not focusing like
Well,
this
that's
and that.
why, yeah, that's why I didn't add any libraries. That's why we
Yeah.
coded, that's why we coded the template library and didn't just pull a template library, because that would have dragged in all the other .NET supporting libraries and opinions, and like, well, if you're using this library, you must use this testing framework, and then you must use this other add-on to this special type of JSON that we use. I'm like, oh, forget it, man. There's no way.
Yeah,
by the time I'm done setting up the dependencies, there's like the actual thing I want to teach is long forgotten.
yeah, I remember me listening about Uncle Bob and saying that, oh, database is an implementation detail, you shouldn't worry about it. But then I always got caught up into implementation details that matter because my programming style was so coupled to the database.
Yeah.
But now doing this event sourcing, I just don't care. It's put an interface there, it doesn't matter.
This
but
is what
definitely
Yurdis
the
is
paradigm.
talking about. And this is on GitHub if you guys want to look. So it's a time tracking thing. It's one slice of a large event model. But here's the event sourcing part. We're serializing something and writing it to a directory called events. That's it right here. That is your event sourcing. That's how. This is how hard event sourcing is. It's a one-liner, right?
I'm so happy about it, Adam, that you used a simple example of a file, because you also could say, oh no, you have to use get event store, and it's not possible with DynamoDB or X, Y, Z, right? But it doesn't matter. It should not matter.
It shouldn't matter, exactly. And you know, the only thing we have here is if from that same page we made it a post. In other words, someone got a new time entry. Otherwise, well, in either case, we show what the time entries are. And so this fill template is our first read model, and it's not materialized. So literally what we're doing is enumerating all the events, filtering them to show like what yesterday and today, you know, what time entries we had yesterday and today, just as a reference on that same time entry page. So that's all we're doing. So it's again, nothing in terms of special libraries. It's simply reading the files, aggregating them. I'm not sure if people are familiar with that. This is for the technical people in the audience, but we iterate over them and just add each event to make a model of what yesterday and today was. And the part that we spent the extra lines of code here to do everything else is all to do with the templates and this template language, which allows you to interpret this mustache bracket type of encoding for ranges. You know, if I want to show all the entries, it repeats here for all of the entries for yesterday and all the entries that we have for today. And then we have our form for actually adding extra entries as we're working. So all of that is pretty much done in 160 lines of code without the help of any external libraries except the standard library. So that's my preferred way of trying to teach concepts. And the only reason I started going down the rabbit hole of templating is so that we weren't stuck in some .NET specific web framework, so that this would be applicable across any language. You could easily translate this, or even just translate whatever I came up with here and do a search replace for some encoding in your favorite stack and use the same thing and just ignore all the other code that I put in here. But I definitely wanted something to, you know, you just hit the green button here and things run. So that's all. And then when we were going through the template filling, I think this is what you're talking about, Yurdis, where we started to just rename parts of it so that we knew what was going on. So one or more model instances, if we have those for this particular thing, then we get them. Otherwise, oh, right, yeah, so that we populate, this is the recursion, so we can have nested ranges. And then when we actually substitute values or things are just literals. So anyway, it's fun. This is on GitHub. If you, I guess I'll post a link in the chat if you guys want to look at it to do this. You should be able to translate this very easily to Golang or Node.js or anything else that you're more familiar with. Oh, someone already did it. That's perfect. Yeah. So thank you, Stephen, for doing that. The program itself is just the web app, which is just listening for requests.
And I think
then,
yeah, like putting the data as being the important piece of your system, I think is the big change between the two different paradigms. Because
yeah,
I noticed the same in Elixir. I haven't do Lisp, but it's kind of the same. You put the emphasis on the data, so the language itself, it doesn't matter, and it's easy to reason about it once you understand the data, instead of dealing with all these or these other practices that put the frameworks and the programming language to be the important piece of your system.
yeah. So I think you're right, and I think we kind of got distracted. I think we had the right idea with what Fred Brooks was saying uh, a long time ago with "show me your tables and I'll understand what your system is." That meant show me your data so I can understand how your state changes and what your state is to really understand your system. And because of those times back then, it was pretty expensive to store data. So RDBMS and third normal form was the standard, and so that's where those statements came from. But now, really, we don't care what it is. So it's about show me how you store your states. Show me what's on disk, whether that's in a SQL database, whether that's in a NoSQL database, whether that's files, whatever it is. When you turn the power off to your system, what's on disk, what's going on. I'll understand your system. But caveats there for game programming where you have to use memory dumps to understand what's going on. But it's the same thing. It's about state. So wherever your state is, can you show that over time? Can you slice it up and explain to me what's going on? And so, yeah, event modeling makes it a lot easier. Now, did we lose Bobby? He dropped off. Oh, no, there he is. Sorry.
Just turn off my camera for a second.
Yeah, no worries. Yeah, I just wanted to ask you if you have any additions from your perspective on how you showed examples and all that kind of stuff. I mean, that's my preference. I know like Krzysztof has done the opposite. He's added all the he's added all the libraries to simulate what would actually happen in a real work environment, which is good. But for teaching concepts, I've taken out a lot of libraries and relied on the standard libraries only.
Yeah, I'm a huge advocate for that approach. In fact, today is just my day where I'm just going to quote Rich Hickey talks to everyone. But there's another Rich Hickey talk called The Language of the System, where he makes exactly that case. I dropped it in the time tracking Slack. Nice. He makes exactly that case that programming language is the least important choice when you're building a system, right? Like it's like an implementation detail. It's like the choice of your database. It's like, okay, pick the right tool for the job. You're an engineer, do the right thing. But the language of the system is the most important thing. And the language of the system is, the data that you're storing and the events and, how things are communicating, conveying data from one component of your system to another component of your system. And that could be, intra-process within your programming language, or it could be a distributed system or whatever. That's the important part of the important language of your system are those data. Getting more specific, event modeling is a great set of disciplines around that important language of the system, because now you have a specific vocabulary. You've got you've got events, you've got read models, so you can start to reason about different parts of your system in different ways. And this is before you've even thought about programming languages. This is just reasoning about state and data over time.
Yeah, I wonder if you have some examples you could show. I'm going to have to take another break for 2 minutes to make sure my son's finished eating and hasn't been distracted by video games and not finished his breakfast. But I'll be right back in 2 minutes. So that's probably a good topic to explore or not just you, Bobby, but if anyone else has some good examples. I know Krzysztof has added way more code to his time tracking implementation, so maybe he can share it too. But I'll be back in 2 minutes. 1 second.
So this isn't any insight, but maybe an interesting experiment for this group. We're focused on a time tracking application. I think it's a really good example app, but there are a couple of sort of community sponsored example app efforts. There's obviously like the To Do MVC, and then there's Real World, which is another, both example apps where there's a, well-designed specification for how they're supposed to work and look, and in the case of real world, it's kind of building like a medium clone, like a blogging engine. I think it'd be really cool if at some point we could get together, this group, and like implement these things using event sourcing and event modeling, and draw the event model, show how we can implement all the features that are in the specification for this blogging engine, front end and back end, and then add features that the other one doesn't have. Like, oh, you need full text indexing? That's easy. You know, without touching any of the code we've already written, we can add full text indexing, right? You know, just little things like that that show some of the virtues of event modeling and event sourcing. That's just an idea. I'm throwing it out there, apropos of nothing.
Yeah, I think about interacting with you all and reading a lot of the Google groups. I see the exact same repeating questions, but we haven't had the time as a community to show cases of those questions, because most people reply in text, but people like me struggle to understand exactly what you meant in the code. So it would be amazing to people start piling it up examples, because I noticed that once you learn like 10 ways to fix things, that's it. That's all it is. But we don't have enough examples of those cases in order for people to bypass the fear. Because I've been there, like trying to embrace it, but then they come with hard questions like, yeah, I don't know how to fix that, and I never did it before. Goodbye, CTO, letting you do that now.
Yeah.
So.
But I promise it works. Just trust me. We can do it. We'll figure it out.
Yeah, I mean, once you read Greg and people like you, Adam, like, it sounds simple, and it is simple, but then is the unlearning piece of it and changing the paradigm in your head that is so complex that some people get stuck, like me, and definitely I need some time code and examples and say, okay, I see what you mean now.
Yeah, exactly. And the devil's always in the details, right? I mean, it's easy to like talk high level and wave your hands all day long. Like, oh yeah, this stuff is easy. You just do X, Y, Z. But like, yeah, I mean, you hit some weird edge case and you're like, oh man, I have no idea how we're going to solve it.
I mean, the funny thing, it is easier though. Like once you see the code, once I have the opportunity to see what Adam meant with event modeling, it's like, that's it. I haven't read that much structs mutation in my entire life. All of these classes representing data, that's it. That's the entire system. And I didn't believe it, because before it's kind of like, really? Why was I, making it so hard for me then? But yeah, we definitely need more examples and things that we could showcase different situations.
Yeah, that would be cool.
Yeah, especially because like there's no, like it's a frameworkless, like there's no frameworks, right? That's the idea. So there's only reference implementations. So like having a catalog of reference implementations would be awesome.
Yeah, and the really cool thing about like real world's my favorite application example, because it's done that. It's built this community around, let's build a real app. You know, to do MVC is great, but it's like trivial, right? I mean, it's almost so simple as to be meaningless. Real world has an API specification. It's got a UI, and you can either implement the API itself and then just test every reference implementation of the UI against that API and make sure that it works. Or you can re-implement the UI in your like preferred UI framework of choice, right? I guess my proposal would be like, hey, let's forget about the UI piece of real world. Like there's 50 different implementations and different frameworks on the front end. We can use any one of them. What if we just implemented the back end piece, the API piece of real world, and we did it in 5 different languages? Because there's tons of different languages, different frameworks that are all implementing the same application, so that people can compare apples to apples, right? They can see, oh, using this language, framework, philosophy, data store, or whatever, it looks like this versus these other ones. So, we could do 5 different implementations of real world using event modeling, or event modeling, event sourcing, build one event model, using ONode or something, build one event model, have all of the event sourcing implementations refer back to that one event model, but implement it in JavaScript and implement it in C# and implement it in Java, implement it in Clojure, implement it in Go, right? It's so that you can see language doesn't matter. We're all using the same event model. We're all implementing the same API spec. It's just, storing these data. And you can do it with different data stores too. Do one in Kafka, do one using event store, do one with JSON files on disk in S3 or whatever, just show how, right, look, we can swap around databases too. It doesn't matter. Like our philosophy is so flexible that we can slice this problem 5 or 6 different ways and all of our implementations end up simpler than any of the nonsense that comes from the frameworks. So, you know, it would be an interesting experiment to see that done.
Hey, Bobby, it's Darren. Yeah, on that final point that you just made, I've wanted an opportunity to ask this question to you guys, and it's about data stores. And in the environment I'm working at the moment, it's a Microsoft shop, and they have pretty much committed to using Cosmos DB, which is partitioned. And our first attempt at using event sourcing and building our materialized views, we were actually using change event feed. And I wanted to ask your opinion and of the group, feeling they have around a distributed change event feed. So within your stream, within your aggregate, your events are replayed in order, but you do not get your events replayed in order across different aggregates or streams, because Cosmos DB can scale out with a high degree of parallelism. And so with your point about you can swap your stores, you can swap your implementation, I just wondered if there's any constraints or caveats on the claim that you made, or can you work around it with the same techniques you would use with out of order messaging with sagas or something like that? So I was just wondering what your thoughts are, if this is a good time.
Yeah, Darren, didn't you use one Cosmos DB per subsystem and then communicate?
Yes, so we've got a relatively small number of aggregates, but what we're doing is our sticking point is actually it's not a sticking point with creating straightforward materialized views or projections for a given aggregate. Our actual problem starts to surface when we need to do the cross-entity and cross-aggregate type aggregations, that second layer of aggregated information, and that's where ordering really becomes a little tricky. So again, with your idea of a reference implementation, I was wondering if we can have a use case that just addresses that second order of complexity rather than the obvious first order of complexity.
I mean, what type of ordering do you want? I mean, you have kind of a time-based with a more or less unique timestamp, but within an aggregate, you can have an event ID or a sequence number or something and have the ordering there. What we did is the change feed from Cosmos DB used that, put it into, for example, either service bus or event grid once that came out, something where you can have more subscribers. So not a queue or something where you have multiple topics or called subscribers, and for different projections you could use just dedicated subscribers per projection that you want to make and kind of subscribe to different types of events. And then you have these aggregate internal ordering or kind of a time-based ordering. So that's why I wanted to know what types of ordering are you talking about that you would wish for?
Yeah, so it's a thing, trying to remember the specific examples I can communicate clearly. Simple aggregations of number of issues between one-to-many and many-to-many relationships, for example. And then the order of when something was added on one side of the relationship versus being removed. And then when you go to replay, because those events across those streams are replayed in parallel, the fact that something existed in the real world when that second event came through doesn't hold true when you replay from scratch and rebuild your entire model. And you have to cater for the fact that as you're bringing this information from multiple streams into your joined read model, that thing may or may not exist at the time that everything's been replayed. Yeah, I can see Bob is nodding his head. He's obviously encountered this issue before.
Yes, I've encountered it. There's not, so it's hard. It's a hard problem, right? So
well,
sort of,
it's not hard if you have if you're using one event store
yes.
Yeah.
for
So
all your services. You get global ordering, and there's not an issue.
yeah.
Yeah,
So
we're in the world of corporate choosing the architecture before addressing the problem.
Yeah, Adam, don't couple to a specific database product here.
Hey, it works on the file system.
in
It
a
works
general
just
way.
fine on the file system.
Yeah.
No product at all.
But it'd be
Wait,
good to it'd be
whose
good
file
for me
system?
to be able to.
No, you
better
have distributed file
articulate.
systems.
It's
We do.
also
So we
important-
just do SSHFS over over the wire to one box.
But you make a good point, because at the moment we've got a whole load of people chasing the latest shiny things in the cloud, and if that precludes or massively increases the cost of implementing something that is closer to the domain and less about the technology, I want to be able to articulate that and not just call upon my lack of experience but my fear. I want to be able to say, hey, look, the community is saying the same thing. You really do want to be using Event Store or Kafka, or to be able to order your events globally or something. I want to be able to go back to these people and express my views, because it's very easy to say, just plow on, we'll deal with it later. And in the world of misappropriated, misunderstood agile, we're just storing up all these problems until later.
I think what happens with the microservices versus monolith argument is that it's a strawman argument. What you're really talking about is highly coupled, not monolith, but lack of abstractions.
Yeah, big ball of mud.
Yeah, big ball of mud. But before that, it's a you're trying to make a canonical model out of stuff. So it's third normal form to the yin yang, where you're stealing information from other concerns and you're not likely to publish it or repeat it somewhere else. I think that's the core of it. And I think you have to be careful when you're making your argument right now that you watch out for that rebuttal. That will just throw the word monolith.